Everybody ready to learn Bitcoin scripts?
Yeah.
If you don't have your laptop, get it out because there will be some live coding. We're going to write a Bitcoin script. You're going to have to do, possibly for some of you, your first smart contract. So let's get into it. I'm going to begin with a short lecture, and then we'll get into the scripting. So, lecture time. So for help. Can I scroll? I can scroll. Sweet. All right, I'm going to scroll on the mouse. So you can follow along. I recommend that you pull up this slideshow by going to this URL. If you pull that up on your laptop, you'll have a copy of this whole slideshow, and that will give you access to the code that we're going to be copy pasting from here into your developer environment. Also, one of the things you might want to take a look at is my GitHub, where what we're going to be building today is right here on GitHub. So an easy thing for you to do is just like copy this file. If you want to skip ahead to the end and have what we're going to build, this is what we're going to make. You can clone this GitHub and you'll have it. There's a link to the slideshow. This is what we're going to build today.
I've got a question.
Yes, Steve.
So why is there some like random guy lecturing?
So
Super Testnet, why are you here? Who are you?
I'm Super Testnet. I'm a Bitcoin developer, and I'm here because Dee asked me if I would come and get flexible. I make Bitcoin smart contracts. This is what we're going to be building today, and to me, this is the most beautiful interface in the world that you can have. There are no errors on this page, and the user knows exactly what to expect. But if we inspect it, we will see that there's some stuff that happened over here in our console. So what we're going to do today is we're going to create a public key for Alice and Bob. We're going to create a smart contract. This is the address for it. And then this here is going to be a transaction which, if there was any money in this smart contract, it would spend it and give it to me. But you're going to change that and do it to you. Topher, you have a question?
Can you make it bigger? Is
Yes.
there a way to make the console bigger?
I believe Control Scroll might do that, unless this is a Mac. Let's go. Look at that. Beautiful.
Okay.
Is that more legible for everybody?
Yes.
Okay, cool.
Understand it well now.
Huh?
We can understand it.
Oh yeah, now it makes sense. Very good point. So yeah, of course, it doesn't make sense because it's code, but we'll get to it. There's also an IDE right here that I often use for writing scripts, so you can check that out if you want to. You can have it open when it comes time to start writing. First step is to download Bitcoin Core. Raise your hand if you have Bitcoin Core already.
Some of it.
It's not synced.
Some did not sync. There are errors. Things messed up. All right. I think Topher. I think what we might have to do is walk through how to download Bitcoin Core for it. What do you think? Should we do it?
Let's do it.
Actually, could you go back? I didn't copy the URL.
Yeah. If you pull up.
Not
Yeah.
that one.
Sorry.
but-
This one.
Yeah. Thank you.
Yeah. If you copy this, you'll be able to follow along with all the URLs and such. tinyurl.com/btc-script. Let me know if everyone's on the same page, or anyone who needs more time.
More time.
That's the link. Oh, got it. Raise your hand if you do not have Bitcoin Core installed.
Yay!
Everyone's good to go?
I don't have it all the way synced, but I have it installed. I don't know
Yeah, you
what.
don't need to have it
Sorry.
synced.
Okay.
Just install.
All right. This. Yep. Oh, okay.
Sorry.
No problem.
I thought that this thing was available somewhere around this, so that's why I was looking
No, I just made it available right here. tinyurl.com/. Just type that in and you're with us. Good. Okay. So when I do this, I always run Bitcoin Core T with the Bitcoin Qt with these flags, which puts it in the mode I want. I don't know how to do this on Windows. So I think you have to modify like the executable file or like the shortcut if you're doing this on Windows. On Mac and Linux, it should be like this. So I go into my terminal and do this. I don't know to do that on his computer. Topher, come help me.
Sure.
How do
I also want to point out that you can also specify these arguments in your Bitcoin config file.
Yeah, we did that last time, right? This is just to go to reg test.
Yeah. Although there's a couple extra things in here. You can run them, when you run Bitcoin Qt, you can run them as flags, or you can put them in your config file. One of them is tx index equals 1. We're going to need that one. And also, what was the other one? Listen equals 0.
Listen equals 0. Yeah, that will that makes it so that normal stuff breaks and the stuff I want works.
So you can either run this as a flag, if you're able to easily do this and run these flags, or you can just put tx index equals 1 in your Bitcoin comp and listen equals 0.
Where's your Bitcoin located?
Oh, my Bitcoin is located in cd.bitcoin, and in here is my Bitcoin.
Can you run it for me?
Yeah, of course. So this is what I have.
That's not running it, that's displaying the config file.
Yes, that's true. So I'm going to go ahead and edit this for you. Just to give you an example. So I already have server 1, rest 1, actually, I don't like rest. Yeah, rest. So we're going to also want to add tx index equals 1, and what was the other one? Yeah, listen equals 0. 0, and I don't need anything on flag necessarily.
Well, server equals 1 is the same thing.
Yeah. So yeah, you don't really need these. You do need the RPC auth if you're going to use JSON RPC. So we'll get into this tomorrow. You don't have to worry about this. Just the top 4. That's all you have to care about. Reg test equals 1, server equals 1, tx index equals 1, listen equals 0.
If you're using a config file.
If you're using a config file, or you can specify them as flags when you run the executive.
I'm never going to ask this guy to run Bitcoin again. No, I'm kidding. No, Bitcoin's still not running.
Oh, just Bitcoin Qt. Bitcoin Qt.
Great. Okay, it's running over here. Let me pull it over. All right, you should see something like this. Yours might say you're 11 years behind. Does anyone see? Does everyone have this? Actually, everyone raise your hand. All right. If you have something that looks like this pulled up, lower your hand. Okay, we got 2 guys who don't. Looks like. So you do have something like this pulled up. What about you? You got something like this pulled up? Yeah. It's important. I don't want to move forward unless everyone's here on this page, because last time it didn't work out.
The only difference is mine says legacy instead of reg test, and then brackets reg test at the top.
Yeah, that's fine.
That's fine.
You're on reg test. Do what you want. All right, good.
Good question.
Whew. All right, time for the presentation. What is Bitcoin script? Bitcoin script is a programming language that is built into Bitcoin that uses locking scripts and unlocking scripts. These scripts are made of text. This is something Topher went over, right? This is how everyone thinks of a Bitcoin transaction. This is how we present it. This is Bob. Bob has a Bitcoin. He wants to send it to Alice. Alice has a wallet. And so, whoop, sends a Bitcoin into her wallet. As you just learned from Topher, that is not how Bitcoin works. That is an analogy that we use to present it as a user interface to people. What's actually happening, Alice takes the first step. She creates a locking script that is encoded as an address. She presents that to Bob. Bob locks up his Bitcoins to the information in her address. And she keeps the key. She's not going to tell him that key. That would be bad, because then he could take her money. But later, when she wants to move that Bitcoin, she uses her key to unlock the Bitcoins and send them to somebody else. That's how Bitcoin actually works. Important to keep in mind that the locking script and the key are both text. Even here, I'm using an analogy. There's no lock and there's no key. There's 2 pieces of text that have to match up.
Like I can launch it. I just can launch
Everybody with me? Cool. So how do we get from there to smart contracts? Well, we go back to 1996 when Nick Szabo, who's possibly the real guy behind Satoshi's internet, Nick Szabo might be Satoshi. He wrote a paper in 1996 about how you could do smart contracts, and he specified that what they are. He defined them. A smart contract is a set of promises, and he specifies in digital form. I'm going to pause right there because this part is the part that makes the most sense to me. All contracts are a set of promises. Like, I will do this if you do that. It's kind of what a contract is. But these are digital, and that's kind of what I think of as what makes them smart. But he had another idea, which is the second part, including protocols within which the parties perform on these promises. One thing about Nick is that he uses strange grammar, but what I interpret this as, and what I tell people it means, is that there's software that enforces the rules. Protocols are usually encoded or enforced by means of software, and that's how smart contracts are performed. We have software that enforces these contracts. He goes on in his essay to say the primitive ancestor of smart contracts, the humble vending machine. And we've had these since the ancient Greeks. When I was preparing the slideshow, I learned about this ancient Greek guy who made a vending machine that was a water tank that had a slot in it. You could put a coin in the slot, it would fall onto a plate that was actually a lever, and when the coin fell on the plate would start to tilt from the weight, which would unvalve a valve, and water would start coming out. And then as the plate slid, the coin would fall off of it, and it would pop back into a place because of a spring and close the valve again. And that was like the first vending machine, or at least the first one we still have artifacts of. But yeah, we've had these things for a long time, but the cool thing about them is that the contract in a vending machine is embedded into the hardware. The hardware itself enforces what's happening. Like there's a lever and a spring that will only give you water if you give it money. And in the digital world, we can do the same thing with software. We can embed a contract into software so that a person doesn't have to be present. Like with the vending machine, you don't have to go to a judge, you don't have to have the person standing there. The contract is embedded in the hardware in this case, and we're going to embed the contract in software. Any questions about what smart contracts are at this point? Okay.
Any example of a smart contract?
Yes, that's the next slide. Here's some examples of Bitcoin smart contracts. So in Bitcoin, we put our locking script is effectively the vending machine. We put the Bitcoin in the vending machine, inside the locking script. And Alice, if she wants that Bitcoin, she has to supply a piece of text, that's her key, to get it out, to get the Bitcoins out of the vending machine. Some of the pieces of text that we can encode are a proof of purchase, so that she only gets a coin if she provides a receipt to Bob. So like, let's say he wants to buy Skittles from her, he can make her sign something beforehand that's like, I will only reveal this number to you if I've given you Skittles. And then, okay, he's like, okay, I will put my Bitcoins into this machine. The only way you're getting them out is if you reveal that number. She gives him the number, boom, he's got proof that he purchased the Skittles, because her contract says he only gets this number if he gets the Skittles. So that is one way you can do that, proof of purchase. Some people do tokens with Bitcoin scripts. They will use Bitcoin to, a function within Bitcoin called op return to mark an address as special, and then they will treat the Satoshis in that address differently than other Satoshis. They'll be like, these ones represent mark coin, and if I send them to you, you have 32 mark coins, because I marked them as special. You can do swaps. You get X amount of coin A if and only if I get Y amount of coin B. One way that we used to do this in Bitcoin was that the piece of text that Alice has to supply is the private key to some coins on another blockchain. So like, you only get my Bitcoins if you give me the private key to these coins on another blockchain. You can do it that way. Some blockchains still do smart contracts with us that way if you want to do swaps. A lot of them use these HTLC constructions that we got when we added SegWit. That's the kind of the new way we do them, but this still works. So you can do swaps. That's one kind of contract. Uniswap is a famous exchange that uses swaps for doing transfers. This is the one we're going to be building today. The contract we're going to build is called, I call it a ballgame contract. These are also used for elections and for escrow. You get a coin if somebody trustworthy says A, or I get a coin if they say B. So here we got Alice over here in the wheelchair and Bob have a Bitcoin locked up between them, and neither one can unlock it because they need information from this guy. This is Mr. ESPN. He knows a lot about sports. There's going to be an upcoming game between the Packers and the Saints, and he has promised on his website, I'm going to reveal the Packers key if they win, and I'm going to reveal the Saints key if they win. Once he reveals these keys, one of them is going to use it to unlock the coins. It's like the script they're using says something like, if the Packers win, then Bob gets to spend. He has to use his signature plus the Packers key to spend the money. Or if the Saints win, then Alice can use her key plus the Saints key to spend the money. And that would be a ballgame contract. You can also use it for elections. Say, if CNN says that Biden won versus Trump, then then you can have some money be based on that. You can do escrow, where it's like if FedEx says that I got my package, then you get your money. Otherwise, if you don't, I get the money back. You can also do lotteries. Bitcoin supports random numbers, so you can this someone trustworthy is important if you're doing something that interfaces with the real world. But if you're just doing like random numbers, coin flips, lotteries, stuff like that, you don't need a trusted third party to get involved. Bitcoin can handle that itself. And you can encode a lottery where you create a random number and then one party who put money into that address gets to withdraw it. So those are some example contracts. I've built all of these personally. I've made each of these examples. And I hope that when we get to the demo part, you guys will pick one as well, or either one of these or one of your own creation, and make your own smart contract. Sound good? Sound fun?
Sounds great.
All right. A couple of Bitcoin's built-in functions. These are the ones I use all the time. Check sig and check multisig are important for ensuring that only Alice or only Bob gets to spend. We have these things that I call password functions. Normal people call them hashing functions. You guys are computer science people, so you probably would know them as hashing functions. But yeah, I think of them as a password. Like, I'm going to have this piece of text that hashes to this value. I'm going to show you this value. And you can only get the coins if you learn or already know this piece of text. I think of it as a password. You have to know the password to move the coins. But it's really a hashing function. There are time functions. You can have absolute time or relative time. And be like, I'm going to broadcast this transaction today, and you can only spend it on January 1st. Or you can be like, I don't know exactly when I'm going to broadcast this transaction, so I'm going to give a relative time that once I do broadcast it, you can only spend it 6 weeks after that. That would be a relative time lock. We have support for both of those. We have math functions, add, subtract, greater than, less than, equal to. The equal to function also works on strings. So you can compare two strings and see if they're equal. That's what we use when we do like hashes and preimages or pub keys. We say only this pub key can spend, and we'll do not equal there. We have stack functions. Stacks are like arrays. So if you're familiar with arrays in normal languages, you can add some things to an array, and then you can shift them around on there, pop them off, put them on. We call those stacks in Bitcoin. There's two main stacks. Well, there's one called the main stack, and then there's one called the alt stack. And we use them as arrays where we store variables and constants and manipulate them. Everything in Bitcoin ends up in an array. Everything ends up on a stack. And so you'll get very familiar with the stack functions. Depth is like length. If you want to check the length of an array, you use depth. Swap and rotate, change the order of things on a stack. You can drop things with drop or from alt stack, and you can add things with dupe or to alt stack. Boolean functions are my favorite functions in Bitcoin. I use these for this is probably the most powerful tool we have. If you're, as a computer science major, some of you know that Boolean functions are the root of all computer circuitry. Like the computer inside that computer, the microchip inside that computer is just a complex series of AND gates, OR gates, NOT gates. If this electron's flowing through this circuit, but it's not flowing through this circuit, then don't turn on the blinking light. That's Boolean functions. We have all of those in Bitcoin, so we can use them to make anything a computer can do. Branching logic, if then else, also known as AI, which is just a bunch of those put together. We have verify. This is something you put in a script if you want it to only go down this pen path if the previous function returned true. You put verify in there, and that'll cause a transaction failure if whatever his input is false. And then we have op return, which you can use to block off a path. Where you say if you ever encounter an op return, just die. Don't spend this money if somebody did something bad. That's what we use return for. If it's in an input. If it's in an output, this does something else. It puts data on the blockchain you can use to park addresses as special. For a full list of all the functions, check out this website. Bitcoin Wiki has all that on there. A couple of gotchas. These are some of the things to watch out for when you're writing script in Bitcoin. You cannot give custom names to your variables or functions, and this is to my everlasting annoyance because every other programming language lets you do that. Like function coin flip is this, and then you specify all the things you're supposed to do for a coin flip. You can't do it in Bitcoin. You just have to put the function, you have to write the function, but you don't get to name it. Also variables, we don't get to name our variables. You just have to stick them in there and then start modifying them. Script compilers like Bitcoin Lib and Minsk are a workaround. They're like higher level languages that give you tools that you might be familiar with, but they're incomplete. Like Minsk only supports creating addresses but not spending from them, and Bitcoin Lib is JavaScript, so there's that. You cannot write a function once and call it twice. This is annoying, because like let's say I write that coin flip and I want to have 5 people do them. I've got to write that function 5 times now, because I can't like write it once and then call it repeatedly. You can copy paste, which is the workaround for this, or you can use one of these libraries to it'll copy paste stuff for you and compile higher level languages down into Bitcoin script. Another gotcha is the integers have a max size of 2 billion instead of 2 billion, which is not very high. I think in JavaScript the max integer size is 9 quadrillion, which is a lot bigger. But even 9 quadrillion is not enough to do like cryptography or anything. So you can't even do cryptography in Bitcoin, which is a cryptocurrency. At least you can be able to do workarounds, like import libraries and stuff. Integers and strings must all be passed as hex. Bitcoin likes hex. We decided to do everything in hex. That's what we do. Except for the numbers 0 through 16. Satoshi thought those are special because of their own special operation codes. Op 0 through op 16, and then you can stick those on there. You do either one. You can still pass these as hex if you want to, and ignore the exception. But he did think those were special enough to give them their own opcodes. All right, those are the gotchas. Oh no, there's one more. If then else is weird. This is a normal language. This is how if then else usually works. You specify your conditions inside some kind of brackets, and then you specify what paths you should take depending on whether these conditions are true. So if the bread is stale, then check Alice's pub key, and if it's fresh, check Bob's pub key. That's how a normal language would work, not with Bitcoin. In Bitcoin, first of all, the conditions come before the if. You have to specify the conditions that cause if to evaluate before you evaluate. So that's not normal. And also, they have to be a 1 or a 0. Whatever function you're using that you're like checking as conditions has to return a 1 or a 0. And then if it's a 1, you'll do this pack. And if it's a 0, you'll do this pack. Also, Bitcoin script is like Yoda. We speak backwards. Where instead of saying, check Alice's signature, we're like, here's Alice, check your signature. And then you'll be a real Padawan. So, those are some gotchas. Everyone ready to write?
Actually, a question about this. An
Yes.
example would be great. Like when you say 1, 0, anything that evaluates to 1, 0. Okay.
Yeah, and you can have any function that you want. Like, let's say in JavaScript, if you were doing a conditional logic, this might be a function. Condition 1 might be a function where you say coin flip. If the coin flip returns heads, that's going to be a 1, and then we're going to check Alice's signature. And if it fails, it's going to be a 2, or it's going to be a 0, and we're going to check Bob's signature. You do the same thing in Bitcoin, except backwards.
How do you determine the end of the else path if there's no brackets or done or nothing? Like if it's more than one instruction
There's
in
an
the end.
end if. There's an end if statement, but I didn't put it in here, but the closed bracket is indicated by end if.
Gotcha. Okay.
Any other questions about that? Let's write it. Let's get out your laptops. We're going to write. I am Super Testnet, and I am known for writing stuff directly in the browser because I'm nuts. And that is what we're going to do today. So let's create a file. I've created a little index.html file over here. How do I line it up on there? I'm going to get my text editor and pull that right there. And let's start doing stuff. I'm going to, wow, that made it really small.
You can kill the file browser.
I can kill the file browser? Yeah. I don't know how to do that, or why that would help.
Give you more space on the left-hand side.
Oh. Yeah, well, that's got it. Well, it only did it very slightly, but there you go. Oh, we're good. Copy this. paste it in, and save. Control S. Let's check our page. Did we get any errors? View page source. It didn't live update. Well, it got all this. What's it doing, Topher? Help me. Oh, that's code injected by the live server, so that's fine. I can see that. So we got this. Look, a beautiful page, just like we started out with, only there's nothing happening in the console. So let's get stuff to happen in the console. By the way, is everyone with me and they have a little notepad open where they're copy pasting code from the, is everyone with me? You guys are all doing this?
Not yet.
No, we're still working. All right.
While people are catching up, just so you know, on VS Code, I have a
Neo bin. Nope.
Let me switch text editors. It's not my way, so. Sorry, I thought we should do it.
That's fine. That's fine. I'm just copy pasting text, so it doesn't have to be fancy. I'll just refresh. Close big before. Keep it over there. All right. Everyone caught up and you have a text editor open and we're ready to copy paste some code? All right, let's keep doing it. Next thing we're going to do is this code, which I know it's now hard to see. I might just do this where I minimize when I'm going back and forth between these things. So what is this going to do? I'm going to replace my head tags with this. That didn't work. Replace my head tags with this, and what it's going to do is it's going to import some libraries. So this first library is our old friend Bitcoin.js, who I was just criticizing a minute ago, but he's my dear friend and he lets me. We're going to use him to construct our script. We're also going to use buffer. This allows JavaScript to deal with numbers larger than 9 quadrillion. So we need to do that when we're generating private keys, public keys, and other giant numbers. And then we have this thing called ValueInt Bitcoin, or variable unsigned integer Bitcoin. This has a very specific task late in the process that we'll get to when we get to it. But what it's going to do is it's going to find the length of our script and tell our signing engine how many bytes to sign of our script. Like if it's 165 bytes, sign the next 165 bytes. That's what that's going to do later. Next thing, Alt Tab might work. No, it did not. Grave? No, not that. I'm lost. Topher, come help.
Yeah, sorry, we got stuck with only being able to use one laptop.
I know what browser I'm in.
Because I have like 10 different tabs open, so.
You just open the file and browser.
You have 2 grades?
Yeah.
Okay, yeah, then I can flip back and forth between. So where's the text editor?
Yeah, just right click, open everywhere.
Okay, I really wish there was a taskbar that so I could switch easily.
Yeah, it's down here.
Every time I move the mouse over, it goes away. All right, so the next thing we'll do is go to the next slide, where we're going to create some pub keys. So this will use the Bitcoin.js library, its elliptic curve function to make a random private key and public key for Alice. Then we're going to make a random private key and public key for Bob. We're going to log their public keys. Don't show your private keys to the world. You can show your public keys if you want. And then we're going to have the 2 secrets well, these aren't the secrets, these are the commitments to the secrets. But we're going to reveal the secret that the ESPN is going to reveal if the Packers win. And we're going to put in the hash that the ESPN is going to reveal if the Saints win. So there's going to be an imaginary ball game between these two teams, and ahead of the ball game, ESPN put on their website these two hashes and said, all right, if the Packers win, we're going to reveal a secret that hashes to this value. And if the Saints win, we're going to reveal a secret that hashes to this value. You can use these hashes in your Bitcoin scripts, and then if you lock up value using them, you'll only be able to unlock that value once we reveal who won. Sound good? Sound simple enough? That's what we're going to do. Copy this, put it in your script, and watch me get lost again. See? Text editor is right here. Look at that, I didn't get lost. I'm learning this at PapaLess, I think is it.
Yeah.
I'm going to put these in the body. Of course, in JavaScript you can put script tags wherever you want. I decided to put those ones in the body. Next thing we're going to do is make a ballgame script. So what does this do? This is the script. This is the Bitcoin script we're going to use. Although this is not supposed to be, that's the secret actually that we're going to reveal. It's supposed to say, it's edit only. Well, I made a mistake. When I was showing this last week, I did the same presentation last week, and I left in the secret. That's not supposed to be there, because we're going to learn that later. It should say, let me see if it's, I think it's Packers hash. So substitute this in where it says AB, AB, AB. It's supposed to say Packers hash right there. But I can't do it because I'm in view only mode on this. This is the Bitcoin script that we're going to evaluate later, except the secret's already in there. What does this do? Well, there's an op if, first of all, and this is going to need a 0 or a 1 as input. You might be wondering, there's no 0 or a 1. I thought you told me that this requires a 0 or a 1. Well, we have to supply that when we unlock the money. We have to supply the conditions that cause this script to evaluate the truth. If we don't supply a 0 or a 1 when we're unlocking the money, this will fail immediately because it requires a 0 or a 1 as input. And that's why we have to give it. When we spend the money, we're going to supply a 0 or a 1, and we're going to supply the hash of the Saints if the Saints win. So if we supply a 1, it'll evaluate all this. And what we'll do is we'll take the Saints secret, which is this one, and we will cache it and see if it evaluates to the Packers hash, which is what's supposed to be here. It's supposed to say the Packers hash. Then we'll check if they're equal. And if they are equal, we're going to check Alice's signature. We're going to put her pub key in and check her signature and make sure that they match up. And if they do match up, she'll be able to spend the money. The other thing we can do is apply a 0 to op if, which will then skip this part and move down to else. And then we need to supply the Saints hash, or the Saints secret rather, which we will hash and compare it with this hash. And if they match up with the equal verified, we'll put Bob's pub key in there and check his signature. Then, assuming that all checks out, Bob will be able to spend. And that's our script. That's our ballgame script. It's pretty simple. Is everyone able to follow along kind of with what we're going to do? Great. So pop that in.
I've got a quick question.
Yes, sir.
The Saints hash is not surrounded by quotations, but the other thing is that should we be putting quotes around the Packers hash or not?
We should not
Doesn't
have
matter.
quotes.
Okay.
This was me trying to explain to someone in a previous presentation what secret is actually going in here, and I used quotations because if you put quotations around it, it will put this value onto the stack, and if you don't put quotations on it, it'll take if I put Packers hash in here, then it would take the value of Packers hash, turn it into a string, and put that on there.
Okay.
Which is what we want. So it's supposed to look like this
Like that
one,
one.
but say Packers instead.
Okay.
Can you demonstrate it when you paste it into the notepad?
Yeah, I will change this to the correct value. Just right here, copy that. Watch me go. I'm not even going to get the wrong thing. Boom. And lost it. Control V. So this is now going to say Packers. Don't spell it, put things wrong in your code. It will not evaluate correctly. Save, and we'll move on. Let's actually check and see if we're getting any errors. So I'm going to refresh this. and inspect. And look, we get Alice's pub key and Bob's pub key, and no errors, which is nice. I like it when there are no errors. Anyone else like it when there's no errors? It's always nice.
Still getting the blinds.
Yeah, you should be getting a blank screen unless you open up your developer console. So this is what the user will see unless they go to inspect. Another way to get to it, might work in your browser, is right click up here, click up in the menu, and then go to More Tools, Developer Tools. And that should open up your console, which is where developers interact with JavaScript when they're developing stuff. Does everyone see this now?
So at this stage, Alice and Bob have both sent money to
No.
This ESPN thing.
They haven't sent the money yet.
They haven't sent it yet.
Okay.
Okay.
All we've done is they've got public keys. That's all we've got so far.
But will they send money? Yeah, okay.
They will send money into it.
I'm in the console, but it looks like I'm in the console, but I'm only getting like one gas.
Going through elements.
Elements.
While they're helping out, the next thing we're going to do.
Yeah, sorry to cut you off. Real quick, anybody having trouble opening their console, raise their hand. Mel can help you out. Everybody else can get into their developer console?
Yeah, when I try it, just closes it immediately. Like it opens and then closes. So I know
I'll
how.
help him, you help her. And can you help her?
I might have copied something wrong or something. Like when you inspect here.
Your browser's not letting you, it looks like. Or maybe you might have, click the menu. The one that says update. And go down to More Tools. And then click Developer Tools. Should do the same thing you just did. Okay, that's normal. Move this window. And I was hoping that we would find the developer console.
We're not really
This
busy.
time. Do you have another browser you can use? Try a different one. Good old Firefox. So open up your file in there and then see if you can open up the developer console.
Oh, you just.
Okay, there you go. The console. And you see the pub keys. All right, we're on the same page. You still need help, man?
Yeah.
Yep, you're in the
I was
console.
doing so it's gonna have to like.
Yeah, right, click that. Rename it. Rename it. Add .html to it.
So. You don't think so?
Yeah. I just happen to be now. Okay. And right click and open in. And console. Okay. There's your pub keys. So you're with us? Everyone on the same page now? Topher, you good?
Yeah, just keep.
Okay. So now that we've created our Bitcoin script, we're going to call it with this function over here. And what does it do? Well, we need to create the address that they're going to send the money into, for your question. So we take the script, and when we hash it, we turn it into something called a pay-to-witness script hash, which is what Topher went over. It's one of the address types that we have in Bitcoin. We're going to specify that it's going to be on this reg test network, and we're going to specify that twice because I made a mistake and accidentally only specified it once before, and then everything crashed. So we do it twice, and then it works, because that's JavaScript. Then we're going to log the smart contract address, and we're going to put some money in it. So let's put this in our function, in our page. Copy that. Go over to text editor. Paste it. Save. Now I'm going always, every time. Refresh. Check it out. We got a Bitcoin address. Everyone see that in your console?
You said you had to make an edit to the script?
What?
Did you say you had to make an edit to the script? You had to do something twice?
No, this, I didn't have to make, I did the edit before I made this thing, so, before I made the PowerPoint. Okay, so one thing to notice about this, every time I refresh this page, this address is going to change. So you'll notice it ends in 7HFV here, and if I refresh it, now it ends in J4KWH. So why is it changing? Because it's not changing because of the hashes. So there are hashes in this script for the Packers and the Saints, and those are constant. ESPN's not going to change those. They're going to keep those the same for everyone who's using this contract. But the reason it's changing is because of their pub keys. I haven't saved their pub keys, and every time I refresh the page, the pub keys are changing. Those pub keys are also part of the script. So not only do you need the secret for the Packers or the Saints, you also need the private key or the signature from Alice or Bob. And since the pub keys are in the script, the address changes every time. Make sense? That's why it's doing that. All right, so let's put some money in this address. Copy that. Go to Bitcoin Core. See if I can open up that without breaking anything. Send. Put the address in here. And let's do, I'm going to do 25 million sats is what I'm going to send into that address. 25 million, that's what they're betting on.
I just want to pause for a second. So is everybody, have you already mined money, like mined blocks and received money?
I don't know.
Okay.
You're going to have to do that first.
Yeah, let's go over generate.
You gotta have money to send money, and if you don't have money in your wallet when you send 25 million sats, it's gonna give you an error, so you don't have any money. So before, we have to receive money. Go to the receive tab, create new receive address, and copy it. You guys with me?
Still.
You need to slow down just a bit, at least for me, I don't know.
I'm sorry.
Yeah, no, so,
If you see the syncing on your page, just hit hide.
Okay.
You can get rid of it.
It doesn't need, so what it's trying to do, when RegTest starts up, it creates a new blockchain on your local computer that's just a test block, as indicated by the name test in RegTest. And that block is from 11 years ago. That block it creates has a timestamp of whenever they put the RegTest function into Bitcoin, just a long time ago. So when your computer sees that, it's like, well, I need to sync. I'm 11 years behind. I got to catch up. And so it starts pinging your computer and saying, give me new blocks. Well, there are no new blocks. You just created this test blockchain. So it just gets stuck on 11 years ago until we mine a block. And then your computer will give it that new block and you'll be all caught up. Does that make sense? So we're going to make a block. Why we're going to make a block? To catch up this thing so it's synced, and also so we have money. Blocks come with money. Let's go to, does everyone have Bitcoin Core open?
Yes.
Yeah, in a receive address, everyone's
Everyone
copying.
created a new receive address and hit copy? Great. Go to Window, Console.
you copy the URI or you copy the address?
Copy, I will show you what to copy. When you click this, click Copy Address. Right? So then go to Window and click Console. And when you do, it should open up this, which isn't moving, there it is. It should open up this. This is a programmatic interface for interacting with Bitcoin Core. Everyone see something like this? We're going to create a function. I can't make this piece of text bigger, so I'm sorry that it's going to remain small. I can only make that text bigger. We're going to run a function called generate to address. We're going to paste our address.
Or the number first.
I know. Everyone with me on this so far? Don't run it yet, or it'll give you an error. We need to specify how many blocks we want to generate. You'd think one would be enough, but in Bitcoin there's a rule that miners cannot spend their coins until 100 blocks have been mined on top of their block. So we're going to do 101, that way we can definitely spend the coins. Generate 101 blocks and put all the money that you get from those blocks into this address. Got it? Hit enter. You should see your screen fill up with blocks. Look at all this. Look at all these blocks.
Oh, my
If you-
screen fills up with a blank.
Huh?
I just got a blank.
A blank array? Gopher, you want to help her out?
Sure, I'll help you out.
You can just move here.
We're gonna become best friends.
We got
So do we need to set, this wall you're making with the address that you got from the index that we just generated, or if we already had one in Bitcoin, could we use that Bitcoin? Not sure if this is a valid question or not.
Yeah, use the one that you put when you click receive and click copy address. Use that one.
Okay, so if we already had one though, we can, or should we make a fresh?
I would make a fresh one because well, I don't know why. Because then you're doing what I said. I don't have a good reason for wanting to do it that way.
It's reasonable enough.
Yeah, if you want to ignore me, that's fine.
Can you explain, like, this generated 5,000 bitcoins for me?
How do we
Can you
like
believe
cash
it?
out?
These are fake.
The thing is, like, why 50, why 5,000? Like,
Yeah.
how did each one of these get assigned 50 bitcoin and it's 101 of them?
There's a network rule that when the blockchain started, Satoshi had to decide how many bitcoins each miner should get when they mine a block, as an incentive to keep mining. And he stuck his finger in the air and said 50. That's how many. And so they get 50, and then after a certain number of blocks, it halves. So you only get 25, and then it goes to 12, and then it goes to 6, which is where we're currently at. Redchest is a lot quicker. I think there's a halving every 200 blocks to make these test blockchains not last very long, so you can't go sell your coins to people and then have terrible things happen. Big, fraud and stuff. So these test blockchains don't last very long, but there's a halving every 200 blocks. All right, so that's why 50. He was like, how much? What would incentivize people to mine Bitcoin? They weren't worth anything at the time. They were like a penny a piece. Oh, give them 50. That was it. So now we have money, and we should be able to send money to our smart contract address. And we're gonna send 25 million sats to it. Everyone with me?
Good to get that from the console, or not the
Yeah, I
console.
got it over
Okay,
here.
yeah, that's
From my browser.
Do we need to save the public addresses? Because otherwise, if we refresh, we would lose those.
If you refresh, you'll lose the smart contract
And
address. This is why it's important to use Testnet as well, to use the test blockchain, because if you put real money in here and then refresh, you'd lose it. When you build an actual application, save your users from having this happen. Don't let them regenerate new private keys every time. Save that somewhere, have them write it down or something. There's encoding schemes for that. What's up? Yeah, well, there's a bunch of things I'm trying to show, but I will center at least some of it. How's that? Better? All right. So we're going to pay money to our smart contract address in the amount of 25 million sats. I'm going to hit send. Bitcoin will make you wait 3 seconds to review your contract. Notice that it's sending slightly more than 25 million because it's going to add a 231 sat fee that it's going to go to the miner. So it's that's the fee it decided to use for this transaction. Send. There's our little transaction sitting there in the mempool, not in the blockchain. Hasn't been mined. It's sitting in the mempool on our test blockchain, on our test network, waiting to be mined.
I have a question.
Yes,
I'm getting fee estimation failed. It's not allowing me to send transaction for the Bitcoin.
Yeah, how did you do the fee thing? I'm getting the same error.
I'm getting.
Same here.
Yeah, okay. So click custom instead of recommended.
Okay.
So what it's doing, Bitcoin is trying to find out based on the past blocks how much people are paying in fees, so it can recommend you one. But there are no past blocks, and so it can't find a recommended fee. So you just set one to I did 1 sat per byte or 1,000 sats per kilobyte, which is pretty much the lowest you can go. I mean, you can set it to 0, but then I don't know if Bitcoin Core would let you do 0. So yeah, it doesn't let me go below 1 sat per byte or 1,000 sats per kilobyte. What's up?
Yes, so when I hit send, it says the amount exceeds your balance, even though I didn't follow along and generate.
Remind all those coins.
You have
I wonder if did you mine them to the address that you clicked copy address on that one screen?
You want to
Mine
send
it
some
to the smart
document.
contract address.
You change from BTC to Satoshi.
At the top.
Sending 25 million to Satoshi or 27.
Oh, yeah. This field might be the one. If you're sending 25 million bitcoins, you probably don't have that. Change this to status.
Now do the same
Now you can.
Oh, yeah, that worked.
That work? Okay, you're good?
Thank you. Just a really quick aside, make sure on your Bitcoin core that you're on RegTest. So it should say RegTest at the top, and then when you open the program, you should see a blue color scheme instead of orange. If you see orange, then you're on the main network.
You're losing money.
Yeah.
Yeah, always do your programming on the testnet first. That's important. Except on Lightning. On Lightning, I always test on mainnet, because I'm always setting like 5 sats.
Yeah. So is anybody else having trouble mining blocks and sending money? Raise your hand. I'll help you out. So we're all good? Okay.
Next thing. Why does it always do that? Oh, yeah. I told it to. That's why it's doing it. Because he has hot corners, and I always want to go left instead of right. Okay, next thing we're going to do, we've generated our address, we've sent money into it. Now we're going to do an interlude. The next step would be to spend the money that's in this address, create the transaction, take the money back out, and gives it to Alice or Bob. I'm not going to do that because I want to give you guys an explanation of how Bitcoin's virtual machine operates. So Topher did a little bit of one. He showed you like the op do Bob hash 160 stuff. We're going to go through that at length and show you exactly what the virtual machine is doing. Virtual machine being represented by this bowl. So we have a program. This is encoded in our Bitcoin address. Well, this is the pay to pub key hash. This is not our program. This is not the smart contract. This is a normal spec. This is encoded in the Bitcoin address. And we're going to supply some arguments that cause this to return true. Let's see how that works. We start out with the virtual machine has a current operation it wants to perform, which is the default, if you're starting a script, is put strings or numbers on the stack. This is called the stack, the bowl. And you start with arguments first. So the first thing we see on here is a signature. So we put that on the stack. Next thing, we run the current operation, which is put strings or numbers on the stack, starting with arguments first. Well, here's a string. We're going to put that on the stack. Next, we're going to put strings or numbers on the stack, starting with arguments first. Uh-oh, there are no strings or numbers in the arguments. So we're going to move up here to program and put any strings or numbers on the stack. Uh-oh, there are none. This do is not a string or an argument or a number. This is a function, duplicate function. So what do we do? If there are no strings or numbers, run a function if any. There's a function, there's do. I'm going to stick it down here, and it's going to do it. Take one element, copy it, put both on the stack. It's going to take this element, it's going to copy it, it's going to put both of those on the stack. That is what dupe does. Everyone with me so far? Yeah. This is how the virtual machine operates every time it sees a new transaction. Next, we put strings or arguments on the stack, starting with arguments first. There are none. Move up here, still none. That's not an argument, or that's not a string or a number. That is a function. So, if there are no strings or numbers, run a function. Hash 160. What did that do? Take one element, key, hash it, turn it into this key hash, put it on the stack. Pop it right there. So we run two things. Next, we put strings or numbers on the stack, starting with arguments. There are none in the arguments, so we go up here. That is a string. So we put it on the stack. Everyone see where this is going? Next, we run the next function, which is equal verify. Check if two elements are the same. Fail if not. It's going to check if these two things are the same. I'm going to do an interlude here. Oh, I'm sorry. It takes both of them, and it'll fail. The transaction will fail if those are not the same. That's what equal verify does. Now here's where the interlude is. There's another way to do this, which is to separate equal and verify. There's two functions that have the word equal in them in Bitcoin. There's equal and there's equal verify, and they do slightly different things. If we ran equal here, then when it would compare these two values, check if they're equal, and deposit a 1 if they're equal. So it would put a 1 right there on the stack. That's what equal would do if we had used it. Then we could run the verify function, which checks if there's a 1 at the top of the stack. And if there is a 1, it'll continue, otherwise it'll fail. But that's not what we did. We did equal verify. Equal verify combines those. It doesn't put a 1 in the stack. It just checks if they're the same and then fails if not. So it skips the 1. So back to the operation of the machine. So we put those on the stack. Oh no, we don't put them on the stack. We just fail if they're not the same. And they were the same, so we don't fail. Next thing, put strings or numbers on the stack starting with arguments. There are none here. There are none there. It's a check sig operation. So run a function if any. We're going to run check sig. Put that there. What does it do? If this signature is valid for this pub key over the whole transaction, deposit a 1 onto the stack. Otherwise, deposit a 0. So we take the pub key and the signature as arguments. If the signature matches pub key for this whole transaction, put a 1 in the stack. And that's it. Then we run the next thing, which is put strings or numbers on the stack, if any. There are none. No strings or numbers. Run a function, if any. There are none. If there are no functions, then if there is 1, 1 on the stack, succeed. Bob gets to spend the money. If there's not a 1, if there's not just 1, 1, if this is a 2, or if it's a hash, or if there's like 3 things and the top one is a 1, so the top one's a hash, or the top one's a 0, anything other than just 1, 1, we fail. But here, we're in luck. His signature checked out and he gets to spend the money. That's how the virtual machine operates. Everyone with me? That make sense? Cool. Whew. Time to spend the money. To spend the money, we need to do the stupidest thing, because Satoshi's just a freaking moron. Topher, I'm about to go on a super rant. And
no, don't let me stop you.
this is the worst function that exists in JavaScript. Witness static script witness is there because Satoshi, he likes clean code. And so he wrote Bitcoin Core, and he was like, I want Bitcoin Core to be pristine and nice and fancy and not have any weirdness in it. So he put all the weirdness onto us code developers. What does this thing do? This thing takes our script and conditionally tells us how long it is. Because Bitcoin has 2 places where it uses the script. Once when you're signing, where it needs to know the length of the script, and once when it's executing it. When it's executing it, it doesn't need to know the length, because it'll stop when the stack is empty. But when you're signing, it needs to know the length. And Satoshi, because he didn't want to do things twice, he wanted nice pristine code, he made us write this big monster, which conditionally checks the length of our script and appends it onto the beginning of our script if we're signing. So our signing function knows how much stuff to sign, or otherwise doesn't put it in there if we're executing, because you don't want a variable unsigned length integer on your stack that you didn't plan for to be there. So he makes us put this function, and I don't like this function, so I'm not even going to grace it with a presence in the body of my document. I'm going to put it in the head. So that is right here. Nope, I did the hot link again.
Hot corners.
Hot corners over here. Go to my head. Of course, in JavaScript you can put stuff anywhere, but I like my HTML documents to have. Why did it do page down when I thought I hit enter? Because I probably hit page down, that's why. Enter. Make a new script tag. Once again, it doesn't actually matter where you. I keep hitting page down instead of enter. The perils of working on someone else's computer. I'm not used to where all these keys are. Enter. Paste.
It's really nice computer once you get used to it.
Yeah, it's not the computer's fault. It's my fault for having one that doesn't have sound drivers. You can't record audio. Okay, so we got that in there because I don't mind if my head looks screwy as long as my body looks great. That's how I HTML. Okay, where are we? We got that. Now we're going to spend the money, and this withdraw function to withdraw from the address is rather complicated and has 5 sections. The first section specifies the transaction ID that we're spending money, that put money into our address, the index of the output that put money into our address, the address we're going to spend money into. This is going to be Alice or Bob should replace this with one of their own addresses. This is where they want the money to end up if they win the ball game. We're going to specify how much money we're spending out of this address, which is 25 million sats. If you put a different amount, change this to whatever amount you put into the address. we have to specify a new quantity of sats that should go into the address. You'd think, well, I'm taking 25 million out, I would like 25 million, please. But no, Bitcoin's like, you gotta have a fee. So I take the original, and in this case, I'm subtracting 500, because that's a nice round number. You want to do some fee checking and see what's a good fee for your transaction, and not just hard code 500 like Super does. Then we run the witness script function to recreate the script that we need to run in order to spend this money. So that is what the first part of the withdrawal function is going to do. Copy that. I am going to put that here so that I don't have to refresh the page and then lose this address that has the money in it. I'm going to stick it in here. That's what I'll do. Next.
I'm sorry, then you put part almost part?
Console.
Oh, in the console? Okay.
In the console, yeah. Stick it right in there and don't hit enter yet, because this is only 1/5 of the function. Next, what the withdrawal function will do. So it'll recreate that pay to witness script hash address and specify that's the address we're spending out of. And it will, yeah, that's basically all it does. It specifies it's on reg test. So, yeah. Good. Pop that into there. Copy. Paste it. Next thing.
So, in the console, if you want to go to the next line, are you gonna do like a shift enter?
Yeah, shift enter.
Okay. Thanks.
You're welcome. Next one. This creates a structure called a partially signed Bitcoin transaction. Partially signed Bitcoin transaction is a JSON format that was created for people who want to do multi-sigs with each other. Like if I need to give you a partial, both of us need to sign this transaction because it's spending both our money. So I'm going to sign it, and then I'm going to package it up in a JSON and send that JSON to you, and then you can sign it. We call that a partially signed Bitcoin transaction. We're not actually doing a multi-sig, but this data structure happens to be useful for basically anything. So whenever I'm doing transaction stuff, I use this PSBT format, and it's included in the Bitcoin.js library, so it's already right there. When we're using it, we have to specify an input, so we're using the TX ID and the TX index and the address we're spending from, then we need to specify the UTXO, well, data about the UTXO, which is what script are we going to unlock? What's the locking script that we need to unlock? And then the value, which is 25 million sats. So we put that into our function. Copy. Over here. Shift, enter, and paste. And we're almost done. Then we specify our output. So we use the PSBT function to add an output, which is going to be Alice's address or Bob's address, and 25 million minus 500 sats. Then we sign it. So one of them is going to sign this. We have to pick whether Alice is going to win or Bob's going to win. But we'll specify that when we call the function. So we're just putting in a variable called privkey here. And whichever one we choose to sign it, who's going to win the game, we'll do that. Right click, paste. Next, last part of withdrawing is to get the final scripts. Okay, so I mentioned earlier, and I showed you with the example, that we not only need the program, which is encoded in the address, but we need the arguments that cause that program to return true. And this part in get final scripts is where we do that. We create an array, a stack, and we push a few items onto it. We push the signature of the winner, the secret of whether it's going to be the Packers or the Saints, and in this case, I'm doing op1. This will trigger the if condition, and that'll make it so Alice wins. If we do op1 and she knows the secret and she supplies her signature, she'll win. So we put all those onto a stack, and we return everything and log the transaction to our console. So let's put that into our function and paste it. Hit enter. Look, no errors. Undefined is just JavaScript telling us that we didn't call this function, so it doesn't return anything yet. but we're going to call it just in the next slide. Whew. Here is our withdraw function, and we're going to withdraw from the ballgame address using this secret. So game day happened, the Saints come out, and they lose to the Packers. And so CNN or ESPN reveals this secret is the one that indicates the Packers won. We're going to supply Alice's private key, that's what we're going to sign with. Then we need to supply Alice's pub key, Bob's pub key, the Packers hash, and the Saints hash. We use those to recreate the script that we're going to spend money from. So let's do that. Copy it, paste it into here, and we should see an error. Of course, witness stack to script witness is not defined. Why is it not defined? Because I never refreshed this page when I popped it into my script. So I got to go back to my text editor, grab this stupid function that I put in my head instead of in my body, copy that, paste it here, enter, and then I'm going to rerun the withdraw function and hit enter, and we get this. This is a Bitcoin transaction. And if I copy this Bitcoin transaction, so this is just a hex version of everything we did. Bitcoin expects X, likes X, associated with, well, this is just programmers. Programmers like this hex stuff. So copy that, go over to Bitcoin Core, and open up the Bitcoin Core console, where I will use a command called send raw transaction, paste it. So let me go back so you can all see this. The function we're running, my mouse is in the way, is send raw transaction, and then I just paste the thing. And if I didn't do anything wrong, there I did. I know what I did wrong. I never changed the transaction, the index number. So what I did wrong here, the reason we got an error, missing input, is because back on this line, right here, I specified this transaction ID, which is not the transaction ID of the thing that put money into our address. So you see why this failed? Also because I'm an idiot. That was an accident. It was not meant for teaching. That was just me being dumb.
It's a good teaching moment.
Good teaching moment. You can't spend money you don't have. So let's go get the transaction that sent money into our address. How we do that? Go to Bitcoin Core, go to Transactions, look for the one that sent money into your address. That would be this one. And copy its transaction ID. Actually, I'm going to double click it so I can show you a couple of other things. If you double click it, it shows you a little more detail. This is the transaction ID we need, and this is the output index. So copy the transaction ID, the output index is number 1. Replace this DXID with that. Why is paste not available? Control V.
You're read-only on that document, aren't you?
Of course, that's why it's not available. Thank you. This one. So actually, what I will do, I will go back into here and change it. Here.
Do we also change the user address?
You can change the user address to another one, yeah. Okay, so now I've specified the right TX index and the right transaction ID.
The right address, user address?
I'm not changing that, I'm just going to send it to some random place.
Oh, okay.
Alice is generous and she's sending this to a charity.
But normally, okay.
But normally you would specify
Your
Alice's
address.
address, or whoever's winning would specify their own address. Enter, rerun the ball game function, right there. Hit enter, get the transaction X, and let's see if we don't get an error. Who's with me? Go to, not that one, not that one, this one. Send raw transaction, paste, cross your fingers. Look at that, we got a transaction ID. It's accepted by the network with no errors. And Alice won the ball game, or I guess this Packers won the ball game. Yay! You've written your first Bitcoin smart contract. Congratulations, guys. Let's find out who got errors. Anyone get errors? We got one? We got one?
I didn't guess the transaction.
I just changed this, right? I changed it.
You got stuck.
Where am I gonna put the transaction?
Here, I'll totally gonna help you out.
So that means we just sent 20, whoever was rooting for the Packers, Alice.
Alice is rooted for the
Alice got this 25.
So you got 25 million sats. A quarter of Bitcoin. Minus a fee of 500.
So that'll show what her wallet, whatever that is.
Yeah, but where does it end?
Wonderful.
Isn't that great? You got the money. Any other questions? Okay, so we got homework. Your homework, now that you know Bitcoin script and have written your first one, your homework is to make your own. I like this tool, ide.scriptwiz.app, for doing this stuff. I'm going to just briefly show you this app. When you go, it thinks you're trying to work on the Liquid blockchain, but we're going to use the Bitcoin one, so switch to Bitcoin version 0. And this will give you some helpful tips about how to use it, but I'm going to go over that verbally, so I don't need the written one there. So this gives you an example of adding 1 and 2 together. So there's a distinction between the witness program, this is what's encoded in the Bitcoin address, and the arguments, or here it calls them stack elements, that you supply in order to make the program return true, so you can spend the money. So here, the program is take 2 elements and add them together. That's what the add function do. It takes 2 elements and adds them together, and check if they equal 3. So what 2 elements are we going to supply? In this case, we're going to supply a 1 and a 2. This over here shows you how the virtual machine does, what the virtual machine's doing. The first line deposits a 1 onto the stack, so that's what it does. There's a 1 on the stack. The second line deposits 2, so the virtual machine's just going to stick that on there right next to the 2. Then we go down to the program, and the op-add function takes these 2 as inputs and adds them together. Puts a 3 as a result. So it pops that 3 onto the stack and replaces the 1 and the 2. Then the next thing says put a 3 on the stack. So it does, beautifully puts a 3 next to a 3. And then we run op equal. Op equal puts a 1 on the stack. If you don't do op equal verify. If we did op equal verify, it would just continue as long as it's true, not put a 1. Op equal puts a 1, and that's good because you want the stack to have 1, 1 on it when you go to spend. So that is how ScriptWiz works, and I like it because it shows you the functions you have available. If you type op, it'll show you like all these different things you can use, which is nice for auto-completing your stuff. And then you can also look up that Bitcoin Wiki article for explanations of what each function does.
We can use the equal verify as well, right?
You can use equal verify. If you did equal verify, and that was the end of your script, it would not deposit a 1. It would just continue and then end. And that would not work in this case because Bitcoin only lets you spend if there's 1, 1 on the stack at the end of op input. So equal verify would work if you wanted to do something else afterwards. You'd still use op equal if you wanted it to trigger an if, because then you'd need a 1 to trigger the if. But if you just wanted it to continue and do the next thing, you use op equal verify.
And I'm getting an error, it says, it's when I get raw transaction.
Transaction of
The get raw transaction in the previous step on the console.
Oh, you did get transaction. It's supposed to be send raw transaction.
Oh, send. Okay.
Yeah.
Oh, I thought it's get.
No, it does. When you get a transaction, it gets it from the mempool or the blockchain. And when you send a transaction, it gets it from your input, from whatever you type next to send.
So I think I'm pretty sure I did something wrong. It says.
I made the modification to the console,
Yeah.
where we updated the ID and the index. I resent it, and then I assume you have to rerun
Non-mandatory
from ballgame command, and it generated this.
Well, I don't know. We're getting errors in here.
Sent
Welcome to programming.
mandatory.
I can't keep those errors in my head like I did the other ones. I'd have to look into it and see what's happening.
And you updated your transaction ID.
Yep.
This is not just the function, it's split it. This is the beginning.
After it came back with, it should have come back with this.
I right clicked it.
Oh, with that all. Yeah, this is the
This
end
should
of the
have
function.
been what we got out of
Because you also checked.
Okay.
So I don't do that.
And nothing
So we have
after
to
that?
combine them all.
Yeah, you like pasted it all on the console.
When you click the promise, do you see, fulfilled?
Yes.
This is all one
But
function.
you don't see this part.
Oh, so I had it all.
Can you
Okay.
scroll down?
I thought for some reason I was following him and I just assumed it was one for everyone, but I guess it's not necessarily the case.
Yeah, so
Could be one or two.
it's transactions.
Oh, okay. So that's, I specified a one, so I guess that's a bit of a problem. So it's that right there, right? So I need to just change that to a 0.
I don't know why it didn't,
Read that.
I just researched the thing, like you said.
well, it looks like this has only got, this is not the full thing.
Oh, it's everything.
Yeah, all 5 parts. Okay, super. That's what it was.
So I understand the context. So,
But
I just think we ran into this, be something that needs to.
No. The only thing ESPN did was reveal. This.
No, it's just the withdrawal.
That's the only thing ESPN did. Everything else is run by.
Yeah, the non-mandatory.
Not Rob.
Yeah.
Oh,
Everything we ran into
everybody's getting
in, our web browser. Run by Alice. Trying
Just
to
has
explain
like
only Alice is
Only Alice can claim it because only this secret was revealed. If they had revealed the other secret that hashes to the Saints value,
Right.
only Bob would.
Yeah, that
So it
secret
works.
attached Alice. Am I saying that right?
No, the secret was hashed to,
Oh, gotcha. Since we randomized, yeah.
all the way back when we started.
Okay.
In our,
Because like I'm such a
this, the secret, A-B-A-B-A-B-A-B-A-B,
Okay.
hashed to this.
Cool, alright.
With me?
Yeah.
And our script specified, go to our script, that, this says package hash, not ABABAB. The script specifies that only if we supply a secret that hashes to that 838642, whatever that number was, only if we supply the secret that hashes to that, do we then check Alice's signature and let her withdraw.
Okay.
So when we put in, that's why I had you replace this with Packer's hash. Packer's hash is not ABABAB, that's Packer's secret. Packer's hash was 8642 or something like that.
But Alice can run it.
Yes.
Well, couldn't she remove the sig check?
I know what.
She could remove the sig check if she wanted, but then Bitcoin Network won't accept the things. The money is in the Bitcoin address that has this script.
So, okay.
Running.
Okay.
So she and Bob had to agree on what Bitcoin address to send the money into before they put the money in. And Bob's not going to agree to one that doesn't make her check her signature and get the right.
So Alice runs all this code, she gets that raw transaction. And Alice opens Bitcoin.
Sure.
And then,
Or, I mean, there are APIs, there are websites with APIs that you can pass around.
but in this exercise, she opens Bitcoin 2. She pushes the send button with that raw transaction and it sent it to herself.
And it sends the money out of the Bitcoin address,
To her.
out of the smart contract to her.
That's her way of claiming it.
Yeah, that's her way of saying, I get the 25 million sats.
And so, like, did Alice and Bob both send their balloon keys to ESPN for them to hash it?
Sorry, listen, too many people at
Yeah.
once, sorry.
So did Alice and Bob have to send for their both their balloon keys to ESPN so that ESPN's hash matches ABAB plus their
They didn't have to talk to ESPN at all.
okay.
ESPN puts these early values on their website. ESPN puts these values on their website and says, later, after the game, we're gonna reveal a secret that hashes to this.
Okay.
I changed it.
Alice and Bob then separately, they said, hey, let's use these hashes in our contract. If we learn the secret that hashes to this, then you get the money. And if I learn the secret that hashes to this, I'll get the money. Why do we do that? Because we know they're gonna reveal one, only one of those on one.
And what's preventing one from like using the secret of the other one? Like why can't
We don't only require the hash, we also require the signature. They don't have the other person, they can't forge the other person's signature.
Right.
Can you explain just the end of it again? So the number we got from withdraw from ballgame address,
What do you do with that?
that long hex was the raw transaction.
That was a raw Bitcoin transaction.
And then we did send raw transaction with that. That gave another hex back. What was that hex?
That's the transaction ID.
Why does
Which
it
is
show up?
confirmation that your transaction is in the mempool somewhere.
Okay. Is that why it doesn't show up in BitTransfer's transaction log yet?
It doesn't show up in Bitcoin's transaction log because it wasn't to your Bitcoin core wallet. The Bitcoin core wallet only shows your money, not everyone's money.
But even if I, like, it's still not gonna work until it's put in a block, accepted.
If you put your own address in it, it should show you have a pending incoming transaction, which is waiting to be mined.
And then you can mine it, right?
And then you can
Mine it, and then it's just.
This is registered.
Yeah.
So what's happening is.
Like what's that transaction?
Right, that is likely because, this page, they got me too. I got hit by the same error earlier, which was this page.
So the way we can get around this.
You have to modify this to be something that you got from your own Bitcoin core.
I did, and then I did the TX index as well.
And you still got bad or missing?
Yeah.
What about the TX index?
Did you, sorry, let me go a little bit with her first. Usually what that means is that you never sent the money. So there was a stage when you had to paste in the smart contract address and send 25 million cents. You did that part?
Yes.
Refresh in the public.
Well, I don't know.
I mean, if I send the money, that's going on my
I did, so I had to reset it.
When, you should be able to go to the transaction tab and see your transaction mine is, Did you double click it and got the transaction ID from right here? That's the one that's in your contract? I don't know. I don't know why.
You didn't do your transaction, you just mined it.
I just mined it and.
Yeah, see how it says mine? There should be one that's red that says mine.
Yeah.
25.
Yeah, you're
You
missing
send, you have to send it to the address.
ESPN doesn't have money right now.
Yeah, I don't think ESPN ever gets more.
ESPN doesn't get money out of this.
Don't they hold it?
No, they don't.
They never made this transaction happen.
All they do is just announce the keys and then the secret. Right?
Yeah.
And then just.
They never know that it's even being used.
Whoever wrote the contract, I guess you wrote the contract.
I wrote the contract when, if I ever make a website for gambling on ball games, you might be able to get it from there, or you've taken the class, you can get it from there if you want to use it. But yeah, then you'd have to find somebody to reveal the secret, because ESPN is currently not running a service like this.
Yeah.
But you could make big money by offering a service like that. Let's do it. Custodial gambling. There's a couple of companies in the Bitcoin space that do that. SureBit is one. On the Ethereum blockchain, there's Chainlink. They do that. They run like all game contracts and stuff.
So are they the ones announcing the secret key?
Those companies use this. Yeah, they announce the secret keys.
Essentially anyone could, as long as you're consistent, right? Say,
As long as you're
Ravens played whoever, and these are the numbers you play.
You want to have someone who you don't think Bob's going to go find and say, please, just whatever happens, say just like hackers want it, so that I get the money. Gotta be someone trustworthy. I don't think they do. I think that their idea is get a large number of users and then start showing them ads or something. But right now, I think they're all startups and not making any money yet. Could be, I don't know what their plans are. They could, unless people were willing to introspect and do these contracts themselves, they might be able to make a default contract that gives themselves a cut. Maybe people would use that out of gratitude.
What about the service offering the contract, same thing?
Well, yeah, sure. You could create contracts that give you a cut and see if people use them. That would be fair. People might not. People might cut out the part that gives you a cut. Can't stop them from doing that.
Here's a less technical question. we had to go through a lot, like Alice and Bob had to go through a lot of trouble to get their money.
Yeah.
They had to know Bitcoin,
Well,
right?
hopefully you have like a wallet or a website that automates all this
That's
stuff.
what I was about to say. So how do you, are you actually going to give them that huge string that they have to enter into
Well,
a
no.
website to claim their money, or?
No, because there are websites that are running a Bitcoin Core instance, and if you pass, they have like an API endpoint, which you pass a raw transaction, and they'll put it in the mempool for you. You could offer a service that does that to people who are using your website. Getting transactions into the mempool is pretty easy through APIs. And it can all be invisible to the user. They just see deposit money here, congratulations, you won. Take your money here. The user doesn't have to see all the code, but you as the developer have to see the code, right? Thing does
For the,
that.
you know, the parking pass, you have to keep paying for that, right?
Any other questions?
Or you can just like,
I have a question.
I'm
So
really
after that
$100, like,
work, when you click on the transactions, that's from like is it smart contract that?
Yeah, Bitcoin Core sees that this wasn't from a public key to another public key, it was from a smart contract. So it just says, I don't know what's going on here, doesn't know how to read smart contracts.
I see. Another question. So, given that all these improvements that are happening, like, no one suggested to improve the programming language.
Yes.
Isn't that what hasn't been adopted at all?
I wanna
Like,
redo
these other
Welcome
things
to the
are
world of altcoins. Altcoins exist with other programming languages, but it's really hard. It's really hard to make programming languages that are well designed and non-hacky. There are easier ones. I showed you a couple of examples of the Minsk. If you go to the Minsk website, it looks more like Bash. It's a syntax that looks like Bash, but it compiles down to Bitcoin script. There's a couple of languages that common ones that are used in programming smart contracts are Solidity, Clarity, Simplicity. There are other languages. I have never found it. After I learned Bitcoin script, I have not found it necessary to switch to other languages that are easier. I learned the hard one and then I teach the hard one. But there are easier ones.
What's the most common use for a Bitcoin contract? A smart contract?
Lightning.
Lightning?
The Lightning Network is the most popular usage, which is mostly through the payments. The first example I showed you, where you get a receipt, is mostly what Lightning is. The primary contract that you use in Lightning gives you a receipt in return for a payment. But they do this multi-sig thing that makes it incredibly fast and usually very cheap. To rival like the Visa network, but without Visa. And so that's the most common smart contract that Bitcoin contracts are used for. It's just getting a receipt for a payment.
So that receipt would be generated, like, let's say, I think, Topher showed us an example of an AI that generated the images.
Oh, Dolly-bot.
Yeah, Dolly-bot. So he showed us that. He had to pay US dollars for that to get the proof of receipt, right, the proof of purchase.
Well, he paid Bitcoins for it. He paid, I think it was 1,000 sats to get the image from dollars.
So the dollars are never involved.
Dollars are never involved. You can convert, like you can display for your user, this costs $5, and have their wallet convert that to sats and send it however many sats that is. So the user sees dollars. A lot of wallets do that. They'll show you dollars, and then you actually they're using Bitcoin on the back end.
But just the same way, you could also add a button that says pay with credit card and just use your Visa and then just generate the receipt.
Yes, you can. One thing that's different about Visa and MasterCard is they tend to charge, it's difficult to do low value payments with Visa and MasterCard to PayPal. Because they're like 25 cents minimum fee plus 2.9%. So if you try to do something like Dolly, where these AI websites charge you a subscription model where you pay like 3 cents per image, that either has to be done as a subscription or because the Bitcoin network exists. We can do like microtransactions where you actually pay 3 cents and get your image. Whereas you can't really do that with PayPal, Visa, and MasterCard. They have to do subscription instead. Because they can only do larger value things that aggregate over time.
Even just think about homework.
write a script, we'll evaluate it tomorrow. Your homework is to write your own smart contract, and tomorrow, bring up the ones that work, and we'll evaluate them right live on TV and see what you came up with. Feel up to it?
Yeah.
Or at least start playing around in the script editor and see if you can make something happen.
So evaluated just means it turns out to be a 1 at the end.
It just has to be a 1 at the end, and that means whoever did it can spend the money. I think you can handle that. Write a script that returns a 1 at the end. 1, nothing else.
It's gonna be print 1.
In this hello world, that's called anyone can spell. We use them for software.
Yeah, so hey, we were gonna maybe do a whole nother lecture today about hierarchical deterministic wallets and PBK DF2 key stretching and HMAC SHA-512, but who wants to save that for later? Okay, so I think we're gonna save that for tomorrow. I think we've done enough. Whose brain is like tired right now? Okay, awesome. So I think what we're gonna do, we have a few more minutes left, is like let's make sure everybody got their script working. Finish up any questions you may have for Super. Topher's gonna go over some GitHub stuff, and yeah, I'll save you the HD wallet lecture for tomorrow.